All right, so January 2021, and it says, using a calculator or otherwise, calculate the exact value of this fraction. So you should be seeing the screen, and we have 1 and 4/7 divided by 2/3 minus 1 and 5/7. Now, what we know from fractions is that we can never divide fractions, so we always do, which I've learned recently from my primary school children, the CXC method, which is keep, flip, change. So you keep the first fraction, you flip the second one, and you change the sign. So that's their fun mnemonic that they have used. But before we do that, we're going to change this mixed fraction to an improper. So we'll do 7 times 1 to give us 7 plus 4, which will give us 11/7. We change our division sign to a multiplication, and then we flip the fraction that follows. So what we'll get now is 3/2 minus, and we're changing this to an improper fraction as well. So 7 times 1 is 7 plus 5 will give us 12/7. Now, what we'll do here is to now do the multiplication aspect. So it is 11 times 3, and that will give us 33, divided by 7 times 2, that will give us 14. So from these two fractions, our result in our product is 33/14. Then we have minus 12/7. Now, what we know is that when it comes down to subtraction or division of fractions, we must find our LCM. So we cannot just go ahead and subtract our fractions, whilst we could have done that with multiplication. So we cannot go ahead and say 33 minus 12 and 14 minus 7. Our denominators must be the same, and we do that by finding the LCM. Now, the LCM for these two fractions would be 14. Then we'll go ahead and say 14 into 14 goes 1 time, 1 times 33, that will give us 33, minus 7 into 14, that goes 2 times, and 2 times 12, that will give us 24. So now this is basically saying our two fractions are 33/14 minus 24/14. So our denominators are now the same, and we can now go ahead and subtract. So what we'll have is 33 minus 24, that will give us 9. Our denominator remains the same. So our final answer is 9/14. And this fraction calculates to its exact value. Any questions? All right, so there is a raised hand, but I'm not seeing who it is. Okay, Britannia.
Sorry, could it be done another way without flipping and changing the sign? It was could find the LCM for 7, 3, and 7.
No, if this was an addition sign, then that could have been possible. But this is a division sign. And remember, with division or multiplication, you don't need to find any LCM. So you just go ahead. In case of division, you change your division sign to multiplication, flip the fraction that follows. If it was multiplication, you could just go ahead, multiply your numerator times your numerator, denominator times your denominator. However, when it comes on to addition and the subtraction of fractions, then you must find the LCM once the denominators are different. So what you're saying, you say if this division sign was an addition sign, then yes, you could have went ahead and find an LCM and worked all three fractions in one. But because this is a division, the procedure is different from that of an addition or a subtraction fraction.
Okay, sir, thank you.
You're welcome. Any other question? Yes, Selena, 9/14, very good. So we're now on to part B, and it says, when Megan started working, she was paid $85 each week. After a 6-month probationary period, her pay was increased by 20%. How much was she paid each week after the increase? So there are different ways that you can actually work this. The easier way is, if she was being paid $85 each week and she now received an increase of 120%, it means that now she's being paid 120% of her salary. So you can do that by saying 120 over 100 being multiplied by what the salary was before, which is 85. And this will give you your answer of $102. So that is one way. Very good, Selena. So that is one way of working it. Or we could say, okay, if she's making $85 per week, if her salary is now increased by 20%, what we can do is then to find 20% of 85. So it would be 20 over 100 multiply by the $85, and that will give us $17. So her salary is increased by $17. So therefore, her new salary would be $85 plus $17, and when you do that, you will get the $102. So any way that you choose to work it, your answer would still be the same. But this is 2 possible ways that you can work it. It's a 1-mark question, so I would say go for the easier route once you remember it. It's just 1 mark. And if we're being honest, the 2021 paper, it wasn't difficult, but it was a very long paper. It was long. So I think that was the problem with the 2021 paper. All right, so part C says, in 1965, the population of country A was 2,714,000. And in 2015, the population was 3,663,900. And in part A says, write the population in 2015 correct to 3 significant figures. Anybody? This is an easy topic. This is section 1. So this is where you're getting in the groove of exam. So this is the easy part that you should be collecting your marks from section 1. Proving that you have learned something over the past 2 years or over the past 1. So this is an easy topic, significant figures. Can utilize the chat. So what is the population in 2015 written to 3 significant figures? Very good, very good. Very good, Takis, Ode, Selena, very good. So one of the mistakes that you usually see is where students just did, so this is the first significant figure, second significant figure, third, and they wrote their answer as 366 and leave it as that. But they usually leave off the 0. But you must remember that with significant figures, when you're writing significant figures, each digit must maintain its place of value. So if this 3 was in the millions column, after writing it in significant figures, that 3 must hold the same place of value. So this 3 must still be in the millions, the 6 must be in the 100,000, etc., etc. So each digit that you're writing must still maintain its original place of value. So therefore, you'll write this as 3660. 1, 2, 3. So our 3 significant figures would be the 3, the 6, and the 6. In order for them to maintain the same place value, we add zeros in the other values going that is behind it, in order to ensure that these have the same place value. So just put zeros to hold the value or the placeholder in this case. So that is 2015, the population in 2015 written to 3 significant figures. Part B now asks us to write the population in 1965 in standard form. What would be this written in standard form? The population. Shanicia, check again. We are looking at the population for 1965. That is the population for 2015. So indeed, Selena, it would be 2.714 times 10 to the 6. Remember, you write in standard form, it would be the decimal point is behind the first non-zero digit. So we're moving our decimal point from basically behind the 0 here, and you're moving it 1, 2, 3, 4, 5, 6 places. And that is how we got 2.714 times 10 to the 6, and this is a positive 6 based on the direction in which we are moving. So our answer is 2.714 times 10 to the 6. That is our population in 1965 written in standard form. Part 2 now asks us, it says, determine the percentage increase in the population from 1965 to 2015. Now, there are different ways you can work this, but I think one of the easier ways that you can look at it is, if you remember when you're looking at consumer arithmetic, you looked at a topic called percentage increase, but it was usually more so have to deal with profit and loss in terms of money. But applying that same principle here, those same formulas, you can indeed work out the percentage increase. So first, you can find out the quote-unquote profit using the population here from the 1965 to the population here in 2015. And remember, after finding the profit, now to find a profit increase or percentage increase rather, sorry, you would have the profit over the cost price multiplied by 100. It is the same principle that you are applying here. So you're looking at what was the increase, which would be synonymous to the profit. So you're first working out the increase, then express the increase in the population over the original population multiplied by 100. And that will give you the percentage increase of this population. So first you're looking at what is the increase, and then 2, you're going to do the increase over the original population, and that is being multiplied by 100. So anyone get the answers yet? So you're looking at the increase. So first you have to find out what the increase is. So these are figures of 3,663,900 minus what the original population was, which is 2,714,000. So when you do that, when you do put that in your calculator, what we'll get is the increase in the population, increase in the population would be 949,900. So I've worked out the increase. So now can anybody, this formula is the one now that gives us the percentage increase. So what would be our percentage increase? So I've already worked out what the increase is. You know what the original population is. and you're multiplying that by 100. Very good. 35%. So we're expressing the 949,900 over the original population, which is 2,714,000, and that is being multiplied by 100. So if you remember your formulas from consumer arithmetic, it is the same principle that is being applied here, but it's just that more so when in class, usually only use these formulas when it comes on to working out monetary value. And when you input this in your calculator, you will get 35% as your answer. So the percentage increase in the population from 1965 to 2015 is 35%. Any questions? Free to use the chat or the raise hand feature. All right, so part D now says the ratio of teachers to students, to male students, to female. So we have teachers to male students to female students in a school is in the ratio. So they're now giving us the ratio. It is 3 to 17 to 18. So it is 3 to teachers to, sir, I'm not getting 35%. Okay, let me check that. But 949, 900 divided by 2714123 multiplied by 100. Okay, so probably put it in your calculator piece by piece. So do 949,900 divided by the 2,714,000 because I just did that. And when you do that, you should get 0.35.
Sir, wouldn't it be over everything? Like when you add the two values for the 2015 and the 1965 together?
No, because remember they're asking you for the increase, so they said determine the percentage increase. So first we work out what the increase in the population was. So that is what we did here. So this is the increase in 2015. This is the population in 2015 versus the population in 1965. So they want us to find the percentage increase. So we're looking at between 1965 to 2015, what was the increase in the population? And we're expressing this over the original population, which was that in 1965, multiplied by 100. And that is how you get the 35%. So what we're saying is there was a 35% increase in the population from 2015, from 1965 to 2015. So that is what they're asking you to find. What was the increase in the population? I'm not sure if that is any clearer.
Yes, sir.
Not getting the correct. So let me check that again. So we have 3,663,900 minus 2,714,123. All right, so this should missing a 0 here, but I just put it again in my calculator, and you should get this. So when you do 3,663,900 minus 2,714,000, you should get this because I just 3,663,900 minus 2,714,123. Yeah, I'm getting the 949,900. So I'm not sure. Check your calculator to ensure. Okay, very good. And then you're expressing this 949,900 over the original population, which is, this is the population in 1965, and you multiply that by 100, and that is how you will get the 35%. So Keandre, you can let me know when you get the 35 so we can move on. So you are the marker on this question. All right, very good. So she got it. So in the ratio, it is teachers to male students to female students. And the ratio that was given is 3 to male students of 17 to female students of 18. And the question says, determine the number of teachers in the school. By the way, they gave us that the total number of students is 630. Now, what I want you to realize in this question is that even though in the first part they separated male students to female students, they gave the total number of students as a 630. And this 630 actually includes both male and female students. So, you know, students saw it and they were wondering, like, what next should we do? Is this 630? Who does it belong to? But this 630 actually belongs to the entire school population of the 17 to 18 of male students to female. So now that they asked us to determine the number of teachers in the school, we therefore would need to group this ratio here. So we're going to rewrite the ratio just as teachers to students. And what that will give us is a ratio of 3 for every 3 teachers to the total number of students. The ratio of students will be 17 plus 18, and that will give us 35. So this is the ratio of teachers to students, whether it be male or female. The total ratio of teachers to students is 3 to 35. And now we can go ahead and find what is or determine the number of teachers in the school. So it is 3 to 35, and we are trying to determine how many teachers there are to the total number of students, which is 630. Now, looking at it like this, we can cross multiply, and what you'll get is x is equal to 3 multiply by 630, and all of that is divided by 35. Or it's the same as saying 3 over 35, which is the ratio here, teachers to students. So 3 over 35 multiplied by 630. Very good, Larissa. So whether you want to set it out in this way where it is easy to show where you're cross multiplying, or it's just 3 over 35, the total, multiplied by 630. And, or rather 630 over 35. So the total students over the ratio of students are 630 divided by 35 multiplied by 3. And what you'll get is our answer of 54 teachers. And I think, in my opinion, this was an easy ratio question. So as I said, the paper wasn't difficult, it's just that it was long. And I think that is where the challenge came from last year's paper. And believe it or not, this is the end of question 1.